Hello and welcome to Cafe Astroathens Revamped. It's been about 3 years since I uploaded my last Cafe Astroathens video, and honestly, I really missed it. It's relating coffee to different topics in astrophysics, and I always loved making those videos. And it's been a while. So I thought, now that I've got all this really cool space, both literally space stuff, but also the space to create a Cafe Astroathens studio, I figured it was time to revamp it. So here it is, the new revamp of the series Cafe Astroathens, brought to you from the cafe itself. Over this shot of espresso today, I am going to discuss gamma ray bursts. Cheers! As a throwback to my first episode on the series Cafe Astroathens, I decided that I'm going to discuss gamma ray bursts again because it is fascinating, and I truly do feel like gamma ray bursts are a great comparison to espresso. Because espresso is sort of like the gamma ray of coffee. It is the most concentrated and the strongest of all the other coffee on the coffee spectrum. And similarly, gamma rays are the most energized form of electromagnetic radiation on the EM spectrum. On the electromagnetic spectrum, you have things like ultraviolet radiation coming from the sun, radio waves like coming from my little jazz radio, and you have things like the visible light spectrum, which is how you could see me right now. You also have gamma rays. Now, on one end of the spectrum, you have infrared radiation getting really long and stretched out. Then the furthest is radio waves, very big, long waves. On the complete opposite end, you start to get shorter and shorter waves. This is the wavelength of the radiation. On the furthest end, you have gamma rays. They have the shortest wavelength and the most amount of packed energy when it comes to a burst of these rays. And they are the most intense and bright electromagnetic explosions in the universe. Just like the most intense explosion of caffeine in, quite frankly, the smallest cup that exists when it comes to the coffee spectrum. Now, there are two different types of gamma ray bursts. There are short duration and long duration. So you can probably imagine what that means. It is the amount of time that the gamma ray burst lasts. There are shorter durations, which are from a few milliseconds to about 2 seconds long, and long duration that are from about 2 seconds to several minutes long. And the theories right now point to two different causes of these different types of gamma ray bursts. It's currently theorized that what causes the short gamma ray bursts are the collisions and mergings of neutron stars, as well as the neutron stars falling into a black hole. And when they fall into the black hole, they explode, releasing a gamma ray burst. For long duration gamma ray bursts, the theory currently is that they form as a result of a dying star when it goes supernova. Now keep in mind, a gamma ray burst is about 100 times brighter than a supernova, and about 1 million trillion times brighter than our sun. So these are very, very bright objects. In fact, the brightest objects in our universe. These are really, really bright occurrences. In fact, the brightest and most energized explosions in our universe. Many of them have been detected in distant galaxies scattered throughout our universe. So next time you have your cup of espresso, think about gamma ray bursts, short duration and long duration, single shot or double shot, and enjoy your coffee with a little bit of astrophysics. Thank you so much for watching. If you like this video, feel free to subscribe and leave a comment below. And if you're interested in some exclusive behind the scenes content or to just support my channel, head on over to patreon.com/Astroathens. Thank you so much, and until next time, cheers.